I was not sure if this was the right forum to present this material, because it's absolutely nothing to do with the analysis that we've just heard Hervé and the previous speakers discuss. This is an entirely sort of practical application of the Meteor trail for communications purposes. Anybody in the room who has an amateur radio call sign will probably be able to relate to this better than the purely scientific outlook on it. Anyway, what radio hams do is we transmit signals in fixed periods and then receive for a fixed period of time, then transmit and then receive back and forth, back and forth, back and forth, until we build up enough information to recover a call sign or some signal report or some positional information to constitute what we call a QSO, this contact. As it says there that the state of the art when I started this was tape recorders that recorded at really high speed, they recorded very slow speed, the high speed CW, and then played it back, and you could actually recover the kind of the old-fashioned Morse code from it. But now we've gone to the modern, what they call digital modes, and I'm glad Maximilian mentioned it. WSJT is the sort of new go-to software for this digital communication, which just uses very narrow band audio tones. It makes things easier, but not by much, because there's still the random aspect of the Meteor that you can't account for exactly when it's going to happen. So there's just this continuous transmit, receive, transmit, receive, transmit, receive. So my partner in this particular experiment had played these recordings at an equivalent radio communication conference in Sweden. And he said that the response was quite surprising. So I thought it might be of some interest to the people here, because at the frequencies we're working at, then that's quite unusual. So unlike, again, like Hervé, I could show pages and pages and pages of mathematics, but luckily we don't have the time. So you can roll everything together and basically say that all things being equal, and especially if this book has been quoted so many times, the chapters on forward scatter and back scatter give you all the variables and the diffusion and whatever. The received signal level is generally proportional to or equals a constant times the wavelength to the power 3. The signal duration but the fun for the radio ham is trying it at higher and higher frequencies just to see how far you can push the envelope. If you cast your mind back to Hervé's graphic of the curved Earth, I would be at one station, my companion Ingolf SM6FHZ, the Swedish radio amateur, was at the other position, and we elevated our antennas about 8 degrees, so we're looking at a common volume 100 kilometers above the ground, about halfway between us, which was about 1,000 kilometers. When you bung in some numbers and work out the sort of relative proportions, these are the sort of ratios you get. So the lower the frequency, the longer the wavelength, the more efficient the reflection, which is why the major radars work at 30 megahertz, 50 megahertz, and that sort of wavelength range of 10 meters, 5, 6 meters. By the time you get up to higher frequencies at shorter wavelengths, the efficiencies are falling off. So the pings, as they're called, become shorter and shorter and shorter. So it says there, 70 centimeters, 432 megs. If you get a ping of about 200 milliseconds, that's considered generally quite good. So these are recordings from the Perseids 2024, myself and Ingolf. If you can play the left one. Oh, we're not hearing anything. That's it. So all you get is that tiny burst, but within that, the FSK coding is sufficiently fast that you might get 1 or 2 characters. So you make the first couple of letters, the call sign, and then nothing else. And you just keep doing it over and over and over again until you build up the full call sign and all the data to constitute what they call a legitimate QSO. If you play the second one, please. And it illustrates perfectly the problem. Again, Maximilian was talking about noise. That burst just happened as somebody switched on a kettle or something. But this is entirely typical. When you're at 400 megahertz and above, the reflections are very, very short. However, last year, we tried to get a contact right on the peak of the Perseid. So this was daylight on the 12th of August. So anything longer than half a second gets your attention. So this is a video I have on YouTube, actually. So if you can just play this, we'll just let it run. These are 5 30-second recordings. That was the constituted the whole contact. But the reflections we got were remarkable. So that's the signal here. That was the first burst. You can see all the individual frequency shift tones. That ran to about 2.5 to 3 seconds. So this just is we recorded everything just in case we got something like this, but it turned out to be, these were quite short compared to what we got. And apparently at the other event Ingolf attended, it was this item here that caused all of the interest. So this is Ingolf receiving, this is me transmitting. I'm just sending a call sign over and over and over again. There's the noise burst. And we hear this enormous reflection. Now, what was even more remarkable is when we examined the timestamps of the recordings, this was Ingolf transmitting back to me, but they were consecutive. So the actual echo was lasting about 23 seconds in total. This was just another one that, again, would have attracted a lot of attention on its own. If this is all we had actually got, it lasted about a second or so. And there's another one we have with a noise burst. And this was the last big reflection we got, about 18 seconds duration. If you look really closely, I'll talk about these in a moment, see these little curved lines here? Again, this is what caused a lot of the discussion at the Swedish event. So yeah, let's just take this from YouTube. So we had those 5 30 seconds recordings over 1 hour and 42 minutes of getting the back and forth to complete the contact. But we weren't really aware of how significant the recordings were until Ingolf said there were some people from ISCAT and what have you at the event saying, no, where were these made? Who made them? What was your ERP? What antennas were you using? So they were quite excited by it. So that's just the graphic pasted back to back to show the whole 23-second reflection and this noise burst. And what, again, could you play these again? You don't, sorry, you don't really get the impression of it from the audio, but again, there are these hints of what appears to be the sort of signal dopplering out of this, what might be the head echo. We don't know, because at 432 megahertz, it's just not a frequency that's used for research. So could you play the top one again, please? And the bottom one, it's just to emphasize that there was these strange effects that appeared in the spectrogram. So, I don't know whether this is the head echo or not, or is it some sort of thermal effect, just because of the sensitivity. We're using really nice gas FET preamplifiers, both of us. But once you hear the noise burst and you actually see the data signal, the frequency shift keyed signal, there's no Doppler on it at all. It's just stable for the time, and the call signs and all the data that was there just read out by the sound card and the software. So is there some strange geometry between us? Was it just some freak lucky, series of fireballs? Absolutely no idea. We tried again, and all we got was several hours of the tiny little 100, 200 millisecond bursts. We didn't get anything close to those 4 really long recordings, and more tests are required and more tests are planned. We'll probably be doing it again, the Geminids this year, and possibly the Perseids if we can get together the following year. But they just are, in the communication world, very, very unusual recordings of that duration at such a high frequency. So thanks for listening. Questions?
Thank you. Are there any questions?
Oh, there we go.
Yes, Johan.
Yes.
I was just wondering, do you have absolute measurements on your time series so you know the delay between transmission and reception?
Actually, I don't know. We're both using GPS synchronized clocks. So that's how, as I'm saying, the timestamps are accurate to however many milliseconds. And that's how the whole process works, because the timing is accurate. And that's why you just this back and forth over and over and over again. And that's how we knew that these two certainly tied together. So yes, the timestamps only records to, I think, a second on the file, but it's an accurate second, yes.
Range interval at least.
Oh, yes.
Yeah, because you can figure out with the delay at least how long the signal traveled before it actually reached you, in case there was something else weird going on.
Yeah, well, the other thing, again, apparently the other event, and we're looking at satellites and aircraft scatter and odd tropo effects and what have you, but it was the fact that the longest bursts always happened after this noise burst, and that there was these odd sort of tones doppling out of that. And the distance was just beyond what you could do with aircraft, so it's looking like it was meteor scatter.
We got a question from Hervé.
Bill, when you transmit this, what is the spectral width of what you transmit actually? Because on your the frequency bandwidth was quite large of what you were showing, a few kilohertz, right?
Yeah, the frequency shift keying method uses 4 tones between, I think it's 600 hertz and about 2 kilohertz. But the individual ones are just dictated by the quality of the sound card. So there will be some associated bandwidth, but the signals are intrinsically very narrow. That's how this whole WSJT system works in mass. It's used for moonbound satellite communications. Maximilian mentioned FT8. That was entirely typical. That's some HF user using kilowatts and just, it's harmonics that's been detected. But the actual signal itself is based on the fact that the signal transmitted is accurately timed and has an intrinsically narrow bandwidth.
Any other questions? It's time for a last question. I don't know. If there's any. One in the chat. Okay, please speak up. Felix, you can unmute and speak.
Oh, yes, sorry. I just wanted to ask what kind of antenna is being used for these
I missed this out to just for timekeeping purposes. I was using a homemade array of 4 times 9-element Yagis, and I was running about 750 watts of transmitter power. But that was at my end. By the time it got to the antenna, it was down to about 400 watts, which kept it within our licensing parameters. InGolf was running 750 watts to a 5-meter dish, which is not too efficient at that wavelength, but the ERPs were comparable at about 15 to 16 kilowatts.
Okay, fine. Thank you.
Good. Let's thank the speaker again.